Welcome to our course, Neural Network, and in this part of our course, we are going to talk about some of the challenges in building our neural network model, and this can actually be applied also to building other machine learning models. So basically what we have is having a training data, and then we apply our training data, our model that learned from our training data to a test set or test data. But the problem is that not in all cases we would be able to have a very good outcome because there would there would be some problems when it comes to the kind of data that we have. It could be a problem with respect to the feature selection. It could be a problem with respect to the number of points to consider. And all of these are just actually some of the many problems when we are dealing with building a machine learning model and neural network model. So of course, you know that overfitting is really a big problem because when we are going to deploy our model in a production, the tendency would be that the output would not be good. It would be not convincing. And of course, when we apply that to business, it would not give us the proper return because what we can get is not the real insight that's practical and or having more business value. Let's take, for instance, this kind of situation wherein we consider a certain problem, a certain scenario wherein we have six features, and that we are going to identify and determine the error or the loss function or the loss. So when we say here the loss, it's actually the difference between the predicted value and the real value. When the value is higher, then we can say that there would be a big loss. And of course, when the value is lower, there would be a less or small loss. Our goal here is to always have a smaller value of the loss function because when the loss function, the loss value is smaller, then that would mean that our model is generating something that's very close to reality. So as you all know that a neural network is actually composed of a lot of linear regression. So we just combine all these regressions, and then what we come up with is a neural network. Now we have these situations wherein we have four features. And as you can see, the x1 and the y, which is at the target value, is very similar because the y or the target value is just the twice the value of the x1, and the others would just be, shall we say, not that very valuable when it comes to predicting the value of y because their value can just be 1 or 0. And also, what you can see here is that the number of features is greater than the number of our data points. When we are going to compute for the correct parameter vector for this one is that what we can arrive is do 0, 0, 0, 0, and 0, which means to say that our training model learned perfectly from our train set. When the case is like this, if we are going now to apply our model to the unseen data, the result would be not convincing or convincing because it fits perfectly to our twin data. The reason for this misfit or having a very, shall we say, bad logic of our model is that we have just a very few data set. The scarcity of our data, the insufficiency of our data would make our model having inability to make generalizations for data that it has not yet seen. Maybe you would ask me, how did we arrive at this correct parameter vector? The correct parameter vector or the parameter vector is actually also very related to the loss function that we have just discussed here because the y here is actually the real value and this one would just be the kind of loss, which means to say that having the 0 and 0 and 0 and 0 in this case would mean that there is a perfect prediction and our training set learned perfectly from our twin data. And this means to say that there is no loss to speak of. Only the x1 is not learned perfectly and there is this very little error. Computing this is actually just very simple and I believe everybody knows this one already. So this is just actually with the use of a Gaussian elimination and having all of these things would be able to give you the correct parameter vector. So we have this 1, 2, 0, 0, 0, 0. So I think it's always very important to have a bit better understanding of how all of these things are computed, because this would also give you a proper understanding of our machine learning model, our neural network model.
Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free, like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.